Lately, I've been 3D printing a lot of parts that have to accurately fit together in complex mechanisms, sometimes even printed at the same time, and they have to move independently when the print's complete. And I've been struck by the dreaded elephant's foot. And I thought, look, I haven't really talked about this effect here on Maker's Muse and how I mitigate it with design tweaks, slicer tweaks, and most importantly, setting up your 3D printer properly for that first layer. So if 3D printing things accurately is important to you and you want to get top score on the clearance gauge, watch on. How's it going, guys? Angus here from Maker's Muse and welcome to a 3D Printing 101. I haven't done one of these for quite some time, but this is a topic that I really figured I haven't done a dedicated video on because it really is important and something that's often overlooked. But before I talk about how to mitigate it, I need to explain what the elephant's foot artifact in 3D printing actually is. And this can apply to FDM, filament-based 3D printers, or resin-based 3D printers as well. They both can suffer this effect. And this is how it happens. So the first layer with your 3D print is the most important layer, by far. If it's too far away, the print will not stick, it'll come off the print bed and fail horribly, and too close to nozzle will dig into the print bed and it'll cause all sorts of damage. But often the advice is to make that first layer just a little bit closer than normal so the prints will stick reliably. And slicers often even have settings to make this first layer extremely aggressive. Maybe the flow or the width of the extrusion is increased. Maybe the speed's decreased and the layer height may even be decreased further from the rest of the print's layer height to make sure it's really stuck down well. And that will work really well to keep your print stuck down. But it does have some downsides, and the main downside is the elephant foot effect. And what happens is the 3D printer will extrude too much plastic for that first layer. But that material, that molten plastic, has to go somewhere, so it will start squishing out. And because you constrain the Z height, it only has the X and Y axes to squish out. And this XY expansion can continue quite a fair way up the 3D print until everything normalizes and averages out and the part becomes accurate to the correct extrusion width you actually intended. For a 3D printer where the first layer height is extremely close to the bed, this elephant's foot effect can be very, very obvious. But for some printers, it can be really hard to see and almost completely removed. But it generally exists. There's always just a little bit of extra material in the XY axes for those first few layers, and it's that extra material that stuffs up these models. This is my clearance and tolerance test gauge that I designed quite a few years ago now, but it's still one of my most popular models, and it has clearance gaps of 0.5 all the way down to 0.15, and that's gaps between each wall. So the 0.5 has, in theory, 1 millimeter of total movement. It's 0.5 between each surface. And by far, the biggest issue people have when they print this is the first layers weld together because of that XY expansion, that elephant's foot effect. So when you print it, even though the top surfaces or the edges might look okay, the bottom is just one solid sheet of plastic and you've got no chance of separating the model. So how can we mitigate this? Well, the first place to start would be your 3D printer to try to dial that first layer accuracy in as well as possible. So here's a common misconception with 3D printers. When you home the machine, it will move to 0, 0, 0. That's the start of the coordinate system points, so it'll go from there in the X, Y, and Z axes. And when you're setting your first layer height, commonly people advise to use a piece of paper and then get your nozzle, hone the machine, and then move a bed up or move the nozzle down till it's tightly gripping that paper. But by doing this, you're not actually setting where the nozzle will start printing because the machine will see this as 0. The machine will not try to print at 0. It'll start printing at your first set layer height, which may be 0.15 millimeters or so. So often what I see is people use the piece of paper, they're very tentative setting it so it's barely touching the paper, and then the machine will then go to set that first layer height. It'll be even further away than they expect, and the prints will not stick. So the next thing they do is they wind everything super close and they make that paper really dig into the nozzle between the print bed and the nozzle, and then they go the opposite direction. The prints are stuck down, sure, but the nozzle is way too close for that first layer. We're dealing with tiny measurements here, so you don't have to be too pedantic, but just keep that in mind when you're setting your nozzle height. I just use a piece of paper myself, but I make sure it's usually quite tight, and I will watch that first layer to ensure it's level around the print bed. So for models like this, where there's parts that have to slide in with each other, the first trick I'm going to advise is to use Underside Chamfers in your modeling software. So let me show you how that works. So what I have here is a headphone holder model I recently showed on the channel, and I've done a lot of tweaks to this model to make it easily printable and to mitigate that elephant's foot effect. I did actually mention that video in the final print, and I've done that using a very small chamfer here. So you can see on the other side of this model, it has a very slight chamfer, and it is very small. So small, in fact, that it'll probably be cancelled out by the elephant's foot effect, and it will just look like it's a straight edge when you print it. And every print is going to be different. You might have to figure out what measurement works best for you. But for me, I'll go as small as 0.5 up to about 0.1 millimeters in terms of that chamfer. It really is tiny, and it's a 45-degree angle, so if you're concerned about it printing as an overhang, again, it doesn't matter. But you'll find as that first layer expands, it'll be compensated for by the smaller cross-section, and then as the print continues, it'll average out, and then you'll actually very much mitigate that elephant's foot effect for your 3D print. Now for this one, I do have this little edge here, which is done to support the back of the model, because I also hate using support material. And I haven't done that here because you need at least some contact area for parts to stick properly to a print bed. I find if you're going to do that chamfer here, you'd have like just one line or two lines of contact in terms of an extrusion with filament-based machines, and that's just not enough to ensure connection to the print bed. So I didn't do it on that part, and it's very obvious in the final print to see that that part, the elephant's foot effect, is very pronounced. I even did the underside chamfers to the holes because I find the elephant's foot, especially in holes, can completely block them up. And it's just a good way to save a bit of time. You don't have to go in with a drill and clean out those holes by doing the chamfer on the other side of them. It means that they'll be a little bit more accurate when you do your 3D print. In this example, I have a very complex model. It's a print-in-place puzzle I've been working on. And just to show you a cross-section, it's got a lot of stuff going on. But I needed to print together and not weld together on the print beds. So let me show you how I've done it. I've employed chamfers, but I've also employed generous clearances. And again, the clearance and tolerance gauge is designed to help you figure out what your machine requires, that you can then take those numbers and then use them in your CAD software to inform your designs. Like I mentioned with the headphone holder and that support, I didn't want to reduce that so much that it didn't have any contact area. And similarly with this outer ring, I didn't want to make too small with two chamfers, really reducing that cross section. So instead, I've done a chamfer on the outside part here. That's more just aesthetics because there's nothing interacted with there. I've done just one chamfer on the inside part. So these are two separate parts, two separate bodies. And by doing that chamfer there, it means the parts won't expand due to that elephant's foot effect and weld together. Because if this puzzle welds together on the first layer or two, then it's going to ruin the whole experience. And I've even got a chamfer here for this part here. And then for clearances, because this model is so darn complicated, I went with a 0.6 millimeter clearance because there's just so much going on here. They wanted to make sure that the parts were really far away and they didn't weld at any point. So that model's coming in quite a while. I've still got a lot of tweaks and testing to do, but the first test actually worked quite well. The parts go together like so, and they did actually print in one go on the Up Mini 2 for this case. So that's pretty cool, and that's one way you can also mitigate your elephant's foot effect. But let's say you've already got the 3D printing model, you've got the STL, you don't have access to the CAD files to modify it. What can you do to try to improve the first layer accuracy of your 3D print? What I have here is a slice of that puzzle model, but this slice doesn't have the underside chamfers to compensate for the elephant's foot effect. So if I slice this, and then show you what the cross-section looks for the first layer, these are very close together. And if that first layer squishes out too much, they're going to weld together, and this puzzle is completely screwed if it welds together at the bottom. So how do you mitigate this? Well, luckily, it's actually a well-documented issue, and most slicers now have a setting to let you compensate for this elephant's foot effect. And in prusaslicer, it's called elephant foot compensation. How about that? So to find it, you go to print settings, and then you need to make sure you have at least intermediate mode ticked, where you can see these little yellow icons. And then under advanced, you want to go down to elephant foot compensation. And then a positive number here will reduce the cross section of that first layer. So for example, I'm going to do 0.3 millimeters. and that will reduce the cross section of the first layer by 0.3. Like, it's like an offset. And now you can very clearly see that offset in effect. So the first layer, the lines are quite far apart, and then second layer, they build in by quite a bit, by that 0.3 millimeter setting that we chose. Now, this has saved me many times in the past, absolutely, but there is one issue with this, and it's just the first layer. And you can see it here, the first layer is offset, but the second, third, and so forth are just normal. That might be okay for you, but for some printers, I find that elephant's foot effect can actually be quite high up before it's completely gone, and you need more than just that first layer offset. You sort of need like the chamfer, you need like a gradual transition between that first layer and a little bit higher up. So the compensation, at least in prusaslicer, is just for the first layer. It's worth knowing about, but sometimes it might not be enough. But there's one key issue that none of these tweaks will fix, and sometimes it's really important, and that's the overall height of your model. Say you want to print a 20mm cube that's 20mm high, and you print it on a 3D printer. I give you a challenge, go try it and measure it. It won't be 20mm, it'll be like 19.8 or something a little bit less. Maybe just a little bit less. But unless your 3D printer is absolutely perfectly dialed in, that first layer will be squished a bit, which means the Z height overall of the print will be reduced. So sometimes you just need a perfect model, and you need to use a raft. I know, people hate rafts. I totally get it. If you don't know what a raft is, it's a sacrificial layer of plastic underneath your model that then you peel away afterwards and break away. In fact, rafts are so unpopular now with 3D printers that most people don't even know where to look to actually turn them on. So just in case you don't know, in prusaslicer, it treats rafts sort of like a part of the support material. So you go to print settings, and then you go to support material, and then you can set how many raft layers you want. There's no like just tick box for print a raft. It sort of just offsets the model and then prints underneath it with support. So let's just change this to 2 layers. So you can see here the part is now built on 2 layers of material that is sacrificial, and the part builds up on top of that. It's the job of these 2 layers to kind of take up that inaccuracy, that extra bit of squish, so when the part's built, it's built with the perfect Z height. But keep in mind, we're still printing in layers, so it'll be like a discrete multiplication of your layer height, like 0.2 or 0.15 millimeters. I'm printing this really cool 4-digit combination lock at the moment, and it's got these little gear selector parts inside, and unfortunately the elephant foot effect, even with mitigation, meant they weren't accurate enough, and the parts actually bind up, and the components don't work as well as they should in this mechanism. So I actually have resorted to printing them on a raft, and this is off the Up Mini 2, so I just left them on the raft to show you what it looks like. Don't be scared of using a raft if you need it. It means the parts will be more accurate, it improves bed adhesion, and yes, it does take longer, it uses a little bit more material that unfortunately is wasted, you have to throw it away, but it really can make a difference for getting parts just a little bit more accurate. Because at the end of the day, that's why I have 3D printers. I make them do my bidding to 3D print my designs, my mechanisms, my models, and I will use every trick in the book to make these printers print as accurately as possible so my models actually work. So thank you for watching, guys. Hope you found this video useful on Muse. It's my aim to empower your creativity through technology. I look forward to unveiling all of these prints that I'm working on to you very soon, especially this one. I can't even begin to describe how ridiculously complex this is. Maybe the first puzzle I've designed that is almost unsolvable, but I'm trying to make it a little bit easier. So if you found this video interesting and useful and you'd like to see this puzzle and others on the channel, then maybe consider subscribing, and I look forward to seeing you again very shortly. Catch you later, guys. Bye.